Hi friends, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this power systems through topic wise MCQs, we have completed 5 sessions. It is the sixth one. Okay. And if you want previous, just click on playlist. You can find out all the previous sessions. Let us start the session. If you want download the PDF of electrical engineering subjects, you can visit sunilengineeringacademy.com and from that you can download the PDF notes. Okay. Yes. So in the transmission part, today we are going to discuss transmission line parameters based questions, RLC. Okay. So the coming to the first question, if the conductor diameter decreases, inductance of the line will be dash. A very easy question. We know very well. If you are going to find out the inductance of any line, LA is equal to 2 into 10 power minus 7 ln of d by r dash. R dash is the effective radius. Okay, so r dash is equal to 0.7788 r. So here diameter decreases. That means radius is decreases. So as the radius is decreases, what about the inductance? Increases. So the answer is option A. So the answer is option A. If they are asking about loop inductance, the formula of loop inductance or circuit inductance, then that is nothing but LAB. Okay, that is 2 times of the LA or 2 times of the LB, like that. Okay, so here diameter is decreases, radius is decreases, so inductance will be increases. Coming to the next question, the inductance of a line is minimum when dash. The inductance of a line is minimum when dash. If you can consider the three phase, what is the inductance formula? LA is equal to RL per phase. Here in case of three phase, we need to calculate L per phase is equal to 2 into 10 power minus 7 ln of d by r dash na, d by r dash. Here d will becomes GMD, r dash will becomes GMR, geometrical mean radius. Here mean distance. Okay, so GMD by GMR. So inductance is minimum. If you want make minimum inductance, numerator has to be minimum, denominator has to be more. So then L per phase will be less. Correct? L per phase will be less. So that is GMD is low, GMR is high. So answer is option D. Answer is option D. A very easy question. Okay. Coming to the next one. In case of symmetrical and equally spaced lines having 4 meter, then GMD is dash. Geometrical mean distance is dash. Let us take it is one phase, it is another phase, it is the another phase. Okay. So if we have symmetrically like this and equally spacing 4 meter, 4 meter, 4 meter, then what is the GMD? GMD is equal to cube root of the distance between those, between R and B 4, Y and B 4, Y and R 4. So that is nothing but we will get 4. Okay, so the answer is option D. GMD is 4. Okay, coming to the next one. For the same question, if they have given those are symmetrical but horizontally spaced, horizontally spaced. So let us take like this. The distance between these 4, these 2 is 4. Then what about the distance between these two? 8. So then GMD is equal to cube root of 448. Okay, so that means you will get 4 4 into cubed root to 2, I think. Okay, so this value you will get. That means somewhat of more. GMD is somewhat of more. Okay, so here GMD is more. If the GMD is more, inductance per phase is more. Okay, so to reduce this, to reduce inductance, we need to go with the equally spaced lines. Okay, we need to go with the equally spaced lines. So the advantage of equally spaced lines is we can reduce the inductance. Okay, coming to the next question. In a single phase OHTL line, the internal flux linkages of the single conductor is given by dash. The single phase line, internal flux linkages of a single conductor. A very easy question, direct formula they are asking. If you can consider the two conductors, okay, radius R1 or both radius I am going to take as R, same radius, considering the distance between those is considering as a D. Okay, like a conductor A, conductor B. Then what about the internal flux linkages? Internal flux linkages is equal to between the permeability mu naught mu r I by 8 pi, mu naught mu r I by 8 pi. If you can consider external flux linkages, external flux linkages. In case of external flux linkages, this radius and distance will be come into the picture. So mu naught mu r I by 2 pi into ln of d by r. Okay, so in case of external, between these two we have the air. If we have the air, mu r is equal to 1, so then mu naught by 2 pi into I ln of d by r, ln of d by r. Okay, so this is the formula. So this is for internal flux linkages, this is for external, this is for external flux linkages formula. So internal flux linkages may not depend on r comma d. Okay, so whenever the radius is varies, distance between these is varies, internal flux linkages may not vary, but external flux linkages may be varies. Okay, so keep that point in your mind. Coming to the next question, in a single phase OHTL line, the external flux linkages, just now I have given mu naught into I by 2 pi ln of d by r. So the answer is option D. Answer is option D. Coming to the next question. Coming to the next question. In a single phase OHTL line, the spacing between two conductor increases. Then what about the internal flux linkages? Internal flux linkages formula I have already given. Mu naught mu r I by 8 pi. So the naught depends on spacing. So there is no spacing term. There is no d term here. So you can say no change. You can say no change. Okay. Coming to the next question. In a single phase OHTL line, the spacing between two conductor increases. What about the self inductance of the conductor? What about the self inductance of the conductor? We know the inductance of the conductor 2 into 10 power minus 7 ln of d by r dash. So if you divide with the self and mutual, if let us take it is A, it is B. Self means with own radius. Okay, mutual means with respect to other, correct? So D will comes into the picture. So D belongs to mutual, R belongs to self. So we can make it as 2 into 10 power minus 7 ln of self. Always we are going to take as positive, minus 2 into 10 power minus 7 ln of 1 by D. Okay, generally D is ln of ln of A by B is nothing but, or ln of A into B is nothing but ln of A plus ln of B. So if you want to understand this, I am going to give one more step. ln of D plus 2 into 10 power minus 7 ln of 1 by R dash. Okay, log A, log B. So the A is nothing but D, B is nothing but 1 by R dash. Okay, so now I am going to write this one as directly, and this one I am going to take as 1 by. If you take 1 by, we will get minus. Okay, we get minus. This is belongs to self inductance. This is belongs to mutual inductance. So self inductance depends on radius. Mutual inductance depends on spacing. So they are asking about self. So in the self there is no D term. No D term. There is no spacing. Okay. So no spacing means it does not depend upon the space. So you can say no change is the answer. So no change is the answer. Okay. Coming to the next question. In single phase OHDL line, the inductance of single conductor is given by dash. The inductance of single conductor is given by dash. So many times I have given in this class also 2 into 10 power minus 7 ln of D by R dash. So answer is option E. Answer is option E. Okay. Coming to the next question. In single phase OHDL line, the spacing between two conductor increases. Then what about the capacitance? What about the capacitance? We know the capacitance basic formula epsilon A by D. So as spacing increases, capacitance is decreases. That is the only. Okay. If you want in transmission lines, capacitance line to neutral is equal to 2 times of capacitance between the two lines. That is equal to 2 pi epsilon naught epsilon R by ln of D by R. Okay. So here spacing as D increases, total denominator is increases. That means capacitance is decreases. Okay. Capacitance is decreases. Okay. Otherwise, we have the basic formula of the capacitance. So can directly get the answer as option B. Okay. And always this formula is very important. Capacitance between line to neutral is equal to 2 times of the capacitance between the line. 2 times of the capacitance between the lines. Okay. Here they have given that question. In single phase OHDL line, the capacitance between the line to line is given 2 millifarad, and capacitance between line to neutral is dash. So that is 2 times of the CAB. So 2 into 2, that is equal to 4. Okay. So let us take it as 8. The answer is option B. Answer is option B. Okay. Coming to the next question. If the inductance of the line per phase per kilometer is 4 millihenry, then loop inductance is dash. I have already given the formula. Loop inductance LAB is nothing but also can say circuit inductance. Circuit inductance. Okay. So in this case, 2 times of the LA. So inductance per phase per kilometer they have given 4 millihenry. So that is 2 times of the 4. That is equal to 8 millihenry. So the answer is option C. So the answer is option C. Okay. Coming to the next one. If radius of the conductor is 10 centimeter, then GMR is equal to dash centimeter. GMR is equal to dash centimeter. So we know very well GMR is equal to 0.7788 R. Okay, that is nothing but we can say R dash. So 0.7788 R is 10 centimeter. So that is nothing but we can say 7.788. So the answer is option B. Okay, so the answer is option B. Coming to the next question. A very good question. The conductor of a 10 km long single phase two wire line are separated by a distance of 1.5 meter. The inductance of the line per phase per kilometer is 2 millihenry. Then inductance of the total circuit inductance they are asking. So try yourself. After that, check with my answer. Okay. So total 10 km long is there. Two lines are separated by distance of 1.5 meters. Inductance of line per phase per kilometer is equal to 2 millihenry. So total how many kilometers they have given? 10 kilometers. So total LA is equal to 20 millihenry. Okay. So they are asking total circuit inductance or loop inductance. Or loop inductance is equal to LAB, that is equal to 2 times of the LA, 2 into 20, that is equal to 40 millihenry. So the answer is 40 millihenry. Don't confuse. Per kilometer they have given 2 millihenry, means for 10 kilometer 20 millihenry. Okay. So they are asking circuit inductance or loop inductance, whatever it may be. Circuit or loop inductance is equal to 2 times of the inductance of one conductor. Okay. Coming to the next one. For equilateral spacing of conductor of untransposed three-phase line. It is the very important question. Most of the students will get confused. Okay, so if we have equilateral spacing, then due to this, whenever there is a distance between those conductor is same and the radius is almost same, so inductance is almost same for each conductors throughout the length. So whenever the inductance and capacitances are same throughout the length, then there is no communication interference. No communication interference. Okay, so whenever there is a difference in the inductor and capacitor in the line, then there is a chance of communication interference. Otherwise, there is no chance. Okay, if there is a communication interference, then we are going to take transposition. Why we need to take the transposition? To avoid the communication interference, to avoid the interference between the telephonic lines or communication lines. Correct. For example, if you are going to make horizontal spacing, so the distance between these two is not same, and here throughout the length the distance between the conductors is also not same. So due to the difference in the inductances or capacitances, there may be a chance of communication interference. Okay, whenever the inductance will be changes or capacitance will be changes, so the voltages are different. Whenever there is a voltage difference, then current is flowing. So between the two conductors also little bit of current is flowing. Due to that, noise is entered into the telephonic lines. Whenever near to these power lines, if we have telephonic lines, okay, so then there is a chance of communication interference. There is a chance of noise in the telephone signals. If you are going to talk, we are getting very high noise. Okay, a lot of disturbance is getting. So that is happen whenever inductances and capacitances are not same. In case of equilateral, inductances are same. So whenever there is a same, there is no interference, no communication interference. Whenever there is inductances are same, receiving and voltages are also same. Okay, voltages are also same. Okay, so don't confuse with the untransposed given. Whenever there is a inductances are not same, to make them equal, we are going to transposition. Okay, and coming to the next question. A three-phase overhead transmission line has its conductor horizontally spaced with the spacing between two adjacent conductors equal to d. This is the horizontal spacing. A, B, C. Distance between this is D. Distance between this is D. Okay, between A and C is nothing but 2D given. Okay, and if now conductors are arranged to form an equilateral triangle, so like this, between these is D. Then what about the capacitance and inductance? Okay, first of all, let us calculate GMD. Here in this case, cube root of d into d into d. So that is nothing but d here. So here cube root of d into 2d. Correct? Here between a and c we have 2d. So that is cube root 2 into d. So that means whenever you are converting horizontal to equilateral, GMD is reduces. Correct? GMD is reduces. So we know very well inductance is directly proportional to GMD. As GMD is less, inductance is less. Capacitance inversely proportional to GMD. As GMD is less, capacitance is more. Okay. So average capacitance increases, average inductance is decreases. So the answer is option D. So answer is option D. Okay, all of you clear? We have the capacitance formula, inductance formula, L per phase, 2 into 10 power minus 7, ln of GMD by GMR. Okay, in the same way, C between phase to line is equal to 2 times of between the two lines is equal to 2 pi epsilon naught epsilon r ln of d by r or GMD by GMR. Okay, as GMD decreases, total denominator decreases, capacitance increases. Okay, coming to the next one. If as the spacing between the phase conductor D is increases, what happened to this? Resistance may not depend upon the D. So that is A3, I think. A3. Okay, A3, we have the two options. So can eliminate these two. And what about as D increases, L proportional to D na? As D increases, L increases. C is inversely proportional to D. As D increases, C decreases. Okay, so inductance increase, B2 we have option D is the correct. Okay, option D is the correct. Coming to the next one. The presence of earth in case of overhead lines increase in the capacitance due to earth effect. There is a capacitance is formed between this phase and earth. So due to that, capacitance increases. If the earth effect is increases, so we need to add the capacitances are in parallel. Parallel means total capacitance is increases. So due to the presence of air, capacitance is increases. Okay. If the length of a transmission line increases, what happened to the capacitance? If the length increases, R is equal to rho L by A. So resistance increases, inductance increases, capacitance increases. Okay. So all will be increases. All will be increases. Okay. And coming to the next question. The voltages at the two ends of the line are 132 kilovolt and its reactance is 40 ohms. The capacity of the line is dash. Capacity of the line formula P is equal to EB by XS sin delta. Okay, so if you can consider sin delta as 1, voltages 132, same voltage they have given. Okay, so excess is 40 ohms. So approximately you will get 435.6 megawatt. 435.6 megawatts. Okay, so the answer is option A. Coming to the next one. Series capacitive compensation in EHV transmission lines. Due to series capacitive, what are the advantages we have? The first one, power transfer capability increases. Capability increases. Why? Because due to this, power P is equal to EV by XS sin delta. So, in case of due to capacitance effect, the total reactance is decreases. Total X is equal to XL minus XC. If this capacitance increases, this reactance decreases. This decreases means power will be increased. So power transfer capability is increases. Okay. And the second one, stability improves. Stability improves. Why? Because we know stability is depend upon delta. Okay, delta. As x decreases, okay, as x decreases, we know sin delta will be decreases with the same power. As x decreases, sin delta is decreases. Sin delta is decreases in the sense delta decreases. As delta decreases, stability improves. Okay, and whenever the reactance is less, voltage drop is less. So voltage drop less means you can control the voltage. Voltage control by varying the capacitance, we can control the voltage. So all these three advantages we have. Okay, so we can improve the stability of the system is there. So we can go with that one. We can go with that one. Okay. And coming to the next one, the charging current in a transmission line. Charging current, how we will get the charging current? Due to earth effect, there is a capacitance is formed. Due to this, we are getting the charging current. So capacitive current always leads 90 degrees by voltage, correct? So leads the voltage by 90 degrees. Ferranti effect on long overhead line is experienced when it is dash. Whenever it is a lightly loaded or no load condition, receiving end voltage is greater than the sending end voltage due to charging current. Okay. So this is happened whenever there is a lightly loaded or no load condition. Lightly loaded or no load condition. So the answer is option A. Okay. So the increasing in voltage at the receiving end than sending end voltage. This effect is nothing but Ferranti effect. Just now we have discussed Ferranti effect. A 60 Hz 320 kilometer, it is a long transmission line, lossless line, sending end voltage is 1 per unit. Then what about the receiving end voltage at no load? So at no load or lightly loaded, what is the phenomena we may get? Ferranti effect. It is a long transmission line. 320 kilometer means greater than 160 na, so long transmission line. That is the first condition satisfied. Second condition is no load satisfied. So there is a chance of Ferranti effect, that is due to receiving end voltage greater than sending end voltage. It satisfies. If it is a 1 means greater than 1, only one option is there now. So we can go with the option B. Okay. Coming to the next one. Transmission lines are transposed. Why we are going to transpose? to make the inductances and capacitances are equal throughout the length. Then we can avoid the communication interference, to prevent the interference with the neighboring telephonic lines. The exchange of conductor positions at regular intervals along the line is called as transposition. It is nothing but, if you take Ry by Ryb here, this R will comes here, this Y comes here, this B comes here. Okay, again your B comes here, your R comes here, your Y comes here. Okay, and at final, at receiving end, again Y comes here, B comes here, R comes here. So at a sending and receiving will be same. In between, we are changing their position like this to get the equal distances between the all the conductors. Okay, so due to that, inductances and capacitance will be same. This process is nothing but you can say transposition. Okay, transposition. The insulation is always a voltage phenomena. Okay, so that is designed on voltage concept, switching voltage concept, based on switching voltage. Lightning voltage is very higher, that will be very rare condition we are getting the lightning voltage, so we may not design with that. Okay, if you want design with that, there is a very difficult, okay, a lot of insulation is required. Okay, so what is the value of ABCD constant for a short transmission line? For a short transmission lines, you can neglect the capacitance effect. So we will get the parameters 1Z01. Okay, so 1Z01 in the sense, answer is option C. Answer is option C. Okay. Okay, students, we will discuss the remaining questions in the next session. And students, if you want to download the PDF, you can download from sunelengineeringacademy.com. If you open the sunelengineeringacademy.com, in that you will get the first slide that belongs to how to download the PDF. Okay, just if you open, then you will get sunelengineeringacademy.com. Here you have one video how to download the PDF. Just 1 minute video, guys. Watch that 1 minute video, then you will get the idea how to download. Okay, after adding on all those, you need to log in. Okay, after login, if you click on my orders under downloads, okay, my account, my order downloads, so you will have the downloading links. You can download any number of times. Okay, if you buy any that is the PDF, and if it is not visible, you can send a mail to me. Okay, seahelpline@gmail.com. I will guide you. Okay, and if you try to log in once again, then automatically you will get a file. Okay, that is not a problem. If you add 6 or 7 files, if any one file is missing, try to log out and log in after 1 hour or 2 hours, then you will get the file and download that file. Okay, students, we'll discuss the remaining in the next session. All of you, thank you so much for watching. Take care. Bye, guys.